Zdravo Marko, kako si?
Zdravo, zdravo, evo, odlično. Ulazimo u praznike, tako da to popravlja raspoloženje.
Super. Kada se nalaziš сега? Gdje se nalaziš? Gdje se nalaziš?
Aha. Nalazim se na Rajcu. Rajac je na jednoj planini Suvobor, tu negde u centralnoj Srbiji.
Super. Znači, spremni za 1. maj.
Okay. Da, spremni za 1. maj, za sve ostalo.
Super. Znači, spremni za 1. maj.
Okay. Da, spremni za 1. maj, za sve ostalo. Jel me čujete? Izvinjavam se, ovde se dešava neka buka. Izvinjavamo se, ovo su čari online rada. Ja sam pokušao da ovo bude uživo, ali kažu da je online, tako da se izvinjavam ako ponekad neko dete upadne, nadamo se da neće više. Bio sam dosta glasan. Jel me čujete?
Da. Mislim da smo ok. Така? Окей. Супер, Марко. Значи се познаваме неколку години, 20 да соработуваме заедно со Serverless, само во различни држави, некако. Ако сакаш нешто да ни кажеш повеќе за себе, сам генерално можно да споменам дека долго време си во IT индустријата, работиш како менеджер во Levi9, така да, ако може уште нешто да додадеш и полека да започнем.
Da, pa što se mene tiče, ja prvo sebe volim da predstavim kao matematičara. Dakle, ja sam matematičar odlučio, ovaj MATF, to je matematički fakultet u Beogradu, gde sam nekih kurseva držao, između ostalog, i što se tiče AWS-a, već sam dosta dugo u AWS svetu, tako da sam i trener, imam i nekih specijalizacija i na nivou Levi9 vodim i taj partnership sa tehničke strane, to je jedan sam od vođa partnershipa s tehničke strane i tako, ne znam šta bih im još interesantno rekao. U sebi to je nešto ukratko o meni. Šahista sam i tako.
Super. И па, варете, може да продолжиме понатаму со презентацијата, така да basically we can switch to English just so that everybody can understand everything that is more technical.
Yeah, thank you, Blagoy. So what are we going to talk about today? I'm not quite certain about you when you started your professional careers. I don't know, maybe you were thinking about yourself as someone who is going to start from the scratch and then have some huge companies to invest some huge amounts of money, and you're going to architect from the scratch their solutions, and I was hoping for that as well, but unfortunately, as I said, that's my luck. Maybe you have the better luck, but I actually more often end up in a situation where I join some projects, when I join some company and they are having something that's working already, they're a large company, but it's not working the way that they want it to work for any particular reason. So we are not here to talk about how to set up properly some platform, some type of application in AWS. We are here to talk about something different. We are here to talk how to modify, how to modernize properly some platform that's already working maybe for 2 years, maybe for 5 years, maybe for 20 years. So how to modernize it to use the cloud to its fullest. So it's not only about moving to the cloud, it's actually modernizing, it's actually making it work properly in the cloud. What's the main reasoning behind it? The main reason for doing all of that is simply business continuity. And again, believe me or not, but I don't know how brilliant you are, how smart you are, how good developer you are, how good architect you are, but like it or not, whatever you built, it will become a tech debt. After
Yeah.
a while, someone will ask, "Who did this to you?" And they will actually have some sprints dedicated in order to improve your software, in order to fix whatever you did, maybe not wrongly in the first place, but now it actually needs to be modified. Why? Uh, well, over time, your code base will be outdated. And it's not only the code that you're writing, it's actually also the code that you are sort of borrowing, some libraries that you are using. Um, if you're writing in any programming language, like let's say PHP or something like that, the new versions will become more popular, and you're going to have to switch eventually, etc. Also, um, just think about what we expected from AI, from computers a while ago, from our mobile phones a while ago, and think about what do we expect from them right now. So the requirements will grow, whatever you do. Your customers are going to be more spoiled over time. Your competition will try to attack you, and then they will offer some extra functionality, etc. So at least you will have to build up new functionalities, even though, yeah, your current ones are built perfectly. You are still going to have to extend whatever you are offering. With time, security becomes a problem because, as I said, you're using some libraries. These libraries are having some patches, etc. You are working on some servers. These servers will have some patches that you need to apply. So again, no matter how well you do, you're still going to have to put some effort in order to make it working still. And um, technology changes, of course. Therefore, if you stick with the same old hardware, with the same old way of working things, then it's going to cost more. It is actually going to it's actually going to be more costly than it could be. There will be some services that make something cheaper, or some hardware that's going to make something cheaper, or anything similar. Uh, with all that in mind, people inside the company will change, and the maintainability, how much it actually costs, some TCO, how much it actually costs to run the project, will actually be greatly affected with the fact how outdated or updated your project is. I hope that I explained why we should do this, and I hope that I gave you some ammunition to talk to your business why you should solve some technical depths. And now let's see how to do it. The first thing first, um, if you are talking about 10 years ago, then most of these things, most of the projects that we worked on were on-prem, and that's perfectly normal. That's perfectly reasonable. People were doing that, and that was the way to do it. Then over time, cloud platforms became more and more popular. Right now, whatever you're working, the chances are that you're going to do that on cloud, and with some rare exceptions that are related to some regulatory things, some laws, some clients that are having very specific requirements, you are actually going to build it on the cloud. But what happens if you're having something that's on-prem? um, so cloud is offering a lot of advantages, and people tend to just move their current applications on the cloud. And how do they do that? Uh, the good old friend lift and shift is the first way to go. Basically, you are having some servers, some physical servers. You create some virtual servers and you put it on EC2 the very same way as you would put it on some machine that you installed in some data center of yours. A bit more advanced way.
Probably means the same operating system, the same libraries, without touching anything of the code or the database, how the things are done.
Yeah,
And
basically you're just mimicking whatever you're having on prem, and then just instead of these servers that are physical servers, you are just using the virtual servers. And yeah, as you said, we are mimicking like everything, the libraries, the operating system, and we are opening the ports. We are doing everything that we did on prem. We're just doing it on the cloud. The other, a bit more sophisticated way is containerizing applications. You know the word, even though I cannot pronounce it. Basically, you're just using the Docker or something like that, and then you're actually making the containers, and then you run it in Kubernetes, or you run it in ECS, Elastic Cloud Service. You do something like that, and I have to give it to you. Yeah, it is on the cloud, and it is a bit more sophisticated than just replacing the actual service on EC2. But that's that's still, in my personal opinion, and in an opinion of these people who architected the AWS, is not the best way to go. So AWS is basically stands for Amazon Web Services. So there should be some more services, in particular services that you can use and that can actually bring the best out of AWS. AWS is, or any other cloud provider for that matter, is not something that's living because it's cheaper than the on-prem servers. It's actually working because it's offering much more, and it can tailor some solutions better. So, but so what we are talking about here is good, but just for the start. The
yeah,
next thing is
those two approaches. Will the clients get any benefits for choosing lift and shift versus containerizing the applications? What's your experience with that?
uh, basically containerizing applications is something that, together with, let's say, Kubernetes, uh, that's
Yeah, maybe scaling
EKS,
is
EKS, it's already offering really a lot. It's already offering really a lot on the scalability way. You get you get to use some of the perks of the cloud already. You can, on a click or on automated process, you can get some more processing power. You can serve more clients. When some of these servers are idle, it will scale down, etc. So there are already a lot of perks on using even the just
yeah,
plain lift and shift on EC2, but especially if you're doing containerization. So you're already getting some scalability, which is one of the main reasons for going to the cloud. Anyways, you're already getting that with a containerization of applications. But yeah, that's just some of the perks of the cloud providers. So we are talking about what else can we use from the cloud itself. First question to ask is, and we have to ask it, no matter how much experience you have and no matter how good you are, still there is no one solution, one that fits all. Um, you still have to think about, are we going to do that gradually, or we are going to have some aggressive approach? Meaning that sometimes with some projects that are maybe smaller or that maybe don't have too many users right now, maybe you can do something like Big Bang. Maybe you can say, hey, this software that you're having, it's complete waste of time to do anything to modernize it. You can just start from the scratch, and it's not a big software, it's not a huge software, so you can do it in some reasonable amount of time and then completely switch it. That's That's a possibility, of course, with some types of the projects. If we are talking about something that's a bit more complicated or a lot more complicated, you have to find some more sophisticated strategy. Therefore, one of the ways of doing that is so-called peeling the onion. So you're having the situation where you're having like bunch of microservices, bunch of functionalities that you're offering, and then what can you do with that? The simplest way maybe sometimes is so-called peeling the onion. So you're finding some microservices like the payment microservice or the user microservice or the invoicing microservice, something like that, and you start with that, and then you migrate that thing to build it properly in the cloud, and then you save that core that's most complicated last. Or sometimes the other way around is possible. You start with the most important thing, gain the most of the advances,
Okay.
and then later on you fix these things uh, that are not used so often, anyways. But whatever you choose, most important enabler for these approaches is so-called decoupling. So you have some components and they have to be decoupled. You have to establish some possible microservices, some ways to communicate between the services, so you will be actually able to take it apart, to actually change the way they communicate and to replace any particular component, but only once you decouple it. We'll see a bit more about it later. And yeah, as with most of other things, it's expertise and experience. You have to understand very well what you're doing, and you should have some previous experience on what can go wrong, what can be more complicated than you can actually estimate, which services are most appropriate for, let's say, which amount of data we are talking about, etc. Uh, with
Yeah,
all
and
that,
probably you can choose the different languages when as you're building out this microservices, or even have polyglots databases, so purposely built database and so on. And probably some patterns like strangler fig can help with peeling out the onion if you go in that approach, or the domain driven design patterns or architecture can help us, I guess, in this case as well.
yeah. But the main takeaway is you cannot have one fits all. So for some projects, something will be easier. For some other projects, something else will be easier. You have to find out what works best in that particular use case. And speaking of particular use cases, in that sense, I wanted to give you something that's actually live, that's actually from my personal experience, and that's actually the client who already had a successful business, who came to us to Levi9, and who was, as I said, already on the cloud, but definitely not working very well technically in that particular situation. I will just briefly explain what the business is. So the business is monitoring the cloud costs, and what's the use case? Why someone would use it? Let's say you're having some large company, and you're having some Microsoft 365 accounts. You're having some servers on AWS. You are running some OpenAI on some Azure instances, etc. So whatever you're using, like the cloud costs, the budgets on the Cost Explorer on AWS is very good, and for some other cloud providers, you have something similar, but you need to combine it all at one place, and that's where the business model of this company is. is trying to fit in. How it works? We have a user. It visits some page through the well-known Route 53. Route 53 now goes to some EC2 instance that's running the React.js application. That's single page applications that front end that's rendered on the client side is talking through APIs with some our backend server. That backend server is, I think you are guessing it correctly, it's on EC2 instance, of course, and then on that EC2 instance, you're having some Kotlin application. It's something sort of Java based application using some Spring in there, and it has the Postgres uh, server, and it's on this very same EC2 instance, and it's having some caching as well in Redis, again on the very same EC2 instance. So that application is fetching the cloud cost data from APIs of AWS, of Azure, of GCP, and of Oracle Cloud. If I remember correctly, these are the four cloud providers that are enabled for this particular project. So it's running that these calls in some frequency, fetching the data, putting it inside PostgreSQL, and then serving it to the front end application, which is doing the whole visualization itself. So inside that React.js, you have some libraries like D3 or something like that that are rendering these dashboards and giving end users all sorts of um, interesting and insightful diagrams that are combining the data of all cloud providers, all accounts, and it's also doing some monitoring, some anomaly detection, potentially, etc. So we hope that this is clear, and please feel free to, if you're not asking something yet, please feel free just to tell me which services from AWS you see fitting for something that's done the old-fashioned way, like something is done just on the EC2 instance directly, and there is some AWS service that's dedicated for that. So whatever pops in your mind, what can be replaced, what can you already see that can be replaced, you can just write it in the chat. And we are going to get that done soon. Uh, what was my particular role in this project? So I listened to the client carefully. I understood their business model. I understood what are their goals. I understood what are their problems. Actually, most of all, and we were thinking about what can we offer and what can we um, what sort of roadmap we can create, how do we intend to attack that modernization itself, because as I said, there is no doubt this is on the cloud. So they had absolutely no on-prem servers, everything was on the cloud, but still it was extremely unperformant, and it really lacked some flexibility that you want from the cloud applications or any applications for that matter. One of the things that were problematic is that there were a lot of data, like really a lot of data. If you fetch the data for AWS cloud costs, you will see that you're having some different lines for every hour of every EC2 instance, etc. So there is really a lot of information that needs to be merged and then served. Also, whatever you want to do with this data, you're actually having to build the particular dashboard to show it, and it was really time consuming. The other
Was
thing is,
was
sorry.
this something that the end users were doing? They're creating their dashboards, or the developers?
The
were doing
the end users couldn't create anything complicated. The end users could just rearrange widgets in there. So they couldn't do something too fancy. They could, of course, do some filtering in there. So you can say, give me just the data for that particular tag, or for that particular service, or for these particular services, or for the last month, or for something like that. But they just couldn't create the dashboards that are completely new. So they had to use whatever was already provided for them. But a lot of information were exchanged, and everything else was actually happening on the front end. So the backend would send the raw data to the front end, and then the front end would actually do the visualization. And it worked everything perfectly up until the moment they actually gathered some large clients and some important clients, which actually had the money. So you had a very nice project that's working only for the small clients, and you cannot charge too much for that. And that's actually where when the problem arose. So when we came there, we had a lot of firefighting to do. What's the point? The point is that, uh, as I said, on demo of this project and for the first clients of this project, everything worked perfectly fine. But after a while, you actually found out that, first of all, the Postgres is so-called OLTP, so transactional database, and it's not meant for analytical purposes. So it could fit a lot of data, like really a lot of data, but still not anywhere near to what we needed to do. And how to start working with that? As I said, we cannot just say, "Hey, this is the end goal," and we'll start working on that like at all at once. We we now have to make sure that the application will work, and then while it's working, maybe not the best possible way, we are going to enable it to work better over time. So the idea is to move to cloud native solutions. The idea was to create containers and then to run it in ECS instead of EC2. That's what we're talking about a bit ago. Containers are already much better solution. Then we have Postgres as a just service on as just application on EC2 instance. We were moving that to a service. The same thing stands for Redis. Again, separate it from EC2 instance and run it as a managed service. So AWS is actually taking care about the backup, about the restarting, about the scaling of it, etc. And the very important thing is we had to create it more scalable, actually to scale horizontally, and it meant introducing load balancer and then running multiple of these Kotlin Spring servers and have load balancers in front of them. One more thing that I find very nice and very easy is just getting rid of this thing that's this EC2 front-end server, the React application. It can actually be built and served as static JS files from S3 buckets. So um, if you were following me, uh, we had to start with something that's manageable in a couple of weeks, maybe a month, and to already solve some fire, to already solve some major issues that they had. So it did become much more scalable. It did become easier to maintain because, as I said, you're having some Postgres and then it can scale properly. You're having some Redis as a service, so it can scale properly. It can handle much more than it could previously, and since we are having now containers behind load balancer, we were able at least to scale up. We are still not doing it. We are definitely not doing it in optimized way, but at least now uh, we could brute force way make it work, but just getting more and more servers and get the things done, even not the optimal way, but it still would work.
Yeah, and
Actually,
probably this is highly available architecture since
yeah,
you
yeah,
can
this is,
separate everything and it's not in one server.
yeah,
So,
it's highly available architecture. It's highly available architecture, and the only problem with this architecture is that it still can be very slow and it can be very costly because we are not doing things the optimal way. But at least now we are making sure that our service will always work. It will cost more, it will be slower than it should, but at least it will never break as it was the case previously. And as I said, this is something that's extremely simple. So just create the Postgres, export it, import it in a new service, done. And then AWS is taking care of it. Just take the Redis, export it, import it, done. Just take the React application, build it, put it on S3 bucket, direct Route 53 to that S3 bucket instead of it, done. Create containers out of the Spring application, quite simple thing to do. Instead of running it in EC2, you are putting it in ECS. Very simple thing to do. Instead of targeting the particular EC2 instance, you are now targeting the group of ECS containers. Very simple thing to do. So if you have any experience with AWS, you will understand that everything that we did here was something that's very quick to do. And as I hope that you believe me and that you understand, we already solved a lot. We are still not on our best, but we already solved a lot with very, very low effort. So now let's go to something that we want to do as developers, architects, etc. We want to do it the right way. How does the right way in this particular case looks like? The idea is to uh, take that uh, take that monolith apart and then to split it into microservices and to split it so-called cloud native way, to split it with in having the cloud in a mind and how something should be done on a cloud, taking that into consideration. Let's start from the data ingestion. We can start from any direction, but let's start from data ingestion. As I said, we had a situation where that EC2 instance is fetching some data from the APIs, and then it's putting that data directly into Postgres database. That's not a really viable way to do it, and it breaks our server entirely when that starts. So instead of doing it that way, we actually created a batch job. That batch job would still do the very similar thing. We didn't have to change much code-wise. Still the same functions could work, and these functions were fetching the data from basically from Azure, from Oracle Cloud, and from AWS, and they were putting it a very, very important difference. They're putting it into S3 bucket. What about S3 bucket? This is, if you're not familiar with the concept, so-called ETL process. So extract, transform, load. And if you are into data engineering and data analytics at all, you should understand that we need to separate these three things. So ETL stands for, as I said, extract, transform, load. So don't do it all at once. Please don't do it all at once, even if you can do that, because you should always be able to track down what went wrong. So instead of just fetching the data from API and putting it directly into MySQL. And yeah, God knows how many issues they had because some of these cloud providers just for any reasons changed their API and started breaking. Um, and then you have to fix it, and then you have to find out what went wrong. Here, you're first putting it into S3 bucket. Okay, so the raw data, whatever it finds on AWS API endpoint, it would put it into S3 bucket. And as you can understand, it's extremely simple code. Just fire the API call, put it directly in the S3 bucket, done. The next thing is the glue to the whole ETL process, so-called glue service, AWS glue service, and that was a game changer for this particular company because of the fact that it's user friendly and it can be done through code, but also some business people can see what's going on and can change the transformations itself. So that extra part is finished. Here is the transformation part. So the glue itself is doing the transformation of these actually JSON files that are arriving in S3 bucket, doing the transformation of it and putting it in some format that doesn't go into Redshift, into PostgreSQL anymore. It's actually going into something that's built for the purpose. It's of course um, good old and expensive one, but for the thing it's doing, maybe not that expensive. Redshift data warehouse. Uh, it can actually scale pretty much as your wallet can scale. So yeah, you don't have to worry about if it will be able to scale. You should worry only if you are willing to afford it, if you are willing to pay for it. But it will scale to whatever amount of data you're having. And as I said, having in mind that this company started working with some large clients, that was actually very mandatory. So we would have it in proper data warehouse, and that's where our ETL process is finished, and we have our data. Now let's go from the other way around. We are having our user who's accessing Route 53. Okay, we didn't touch too much there. It was perfectly fine in the beginning. But then we put in the cloud front of the cloud front. Cloud front is, as you are hopefully aware, the CDN. So basically, it does some caching in there. It is having some different ways of protecting us, etc. So we are not pushing directly Route 53 to S3 bucket. We are going to do it through CloudFront. And as I said already, in this short-term way of solving things, we have some S3 bucket, and in that S3 bucket, we are having actually compiled JavaScript files from React front-end application. So that S3 bucket actually contains that React front-end application. React front-end application is not now looking directly at our EC2 instances. It's actually looking into API gateway. And the other thing that's in there is also AWS Cognito, one of the services, the microservices that we identified inside that whole solution is, of course, user management, and that whole EM part, identity management. So instead of doing it the manual way through these through these Kotlin applications, we actually moved it to Cognito, which is extremely important for this particular use case because it could be easier to connect it with whatever these large clients are having. So these are like large clients are having maybe some Active Directory, maybe they're having something else that's actually some federation, and we can connect it directly to the client, and then client doesn't have to create new accounts. We can be directly connected with pretty much no extra coding. So that API gateway, I hope that you guessed correctly, is is targeting one of the most interesting and one of the most um, versatile service of all in AWS. That's Lambda service. That's actually interesting because whatever you need to communicate with, whatever, if it doesn't work like that, just put some Lambda between it, between these services. So that's what we did. We actually moved it to Lambda. And the important thing about this, even though I'm a guy who really hates talking too much about programming languages, because I think that you should always think in some agnostic way about these programming languages. So you should always build your solution. It can work in any language as long as it's yeah, the same way of thinking. Of course, like going to some Lisp or something like that is not the same thing as doing JavaScript. But if you're doing JavaScript or PHP or some Java, etc., they should all be interchangeable if you're asking me. But the only exception to that rule is the JavaScript itself with the front end. So in order to optimize for the cost, we actually built that these Lambda functions in JavaScript, so they don't have to search for expensive Kotlin developers anymore. But the same people could work both on React and on these backend Lambda functions. So we started working on that Kotlin application, tearing it apart piece by piece, like replacing that, as I said, EM functionalities with Cognito, replacing um, some calls with lambdas one at a time, and in the end we had only lambdas. As you remember, in the original solution, and there is nothing wrong with it. It worked with Redis. Redis is um, natively supported throughout the Elasticache service of AWS. So we are calling directly Elasticache. Postgres, we still do need Postgres. Please don't fall for the uh, trap that you need to find one database for your solution that will cover it all. So feel free to mix and match. Feel free to use at the same time some DynamoDB, at the same time some MySQL, at the same time some Redshift, at the same time some maybe MongoDB or something like that. Whatever is good to fit for the purpose. So we still had to do a lot of these things that are transactional, like let's say some configuration or whatever else the clients did over theirs. So we still needed to have a relational database, and uh, we kept the Postgres. There was nothing wrong with Postgres. We just moved it to actually Aurora for Postgres, and yeah, it was much more performant. And something that I have to say, in the end, everything that we did was nice and dandy, but our client enjoyed it the most. I hoped you guessed it correctly, but the quick side part.
Yes. Yeah.
Because all of a sudden they didn't have to pay the expensive developers anymore to build new dashboards. They could actually do it by themselves, and they could actually enable their users to build it themselves. So we were actually creating some um, dashboards in QuickSight, and then QuickSight is BI tooling, by the way, if someone is unaware of that. So we were building some dashboards in QuickSight and then just embedding them inside React front end. It's a huge game changer compared to the building manually these different graphs and having to invest some development time whenever you want to change something about it. So the React front-end application became much simpler. He had to do some basic configuration things, like I create a new subdivision inside my company. I create new whatever you want to do. I don't want to get into details how that application works. But these things had to remain in React application, of course. But the 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 soul of the application are these dashboards, and we could completely outsource them to native service AWS QuickSight. And as I said, similar with Glue, we enabled actually business people to fix and change whatever was required. So yeah, in the end, with all of these fancy technical solutions, our client ended up the happiest with the fact that we had a quick site, and yeah, we just gave them many more ways to improve their application without actually paying developers to create something new.
Okay, and for you mentioned that for the short term approach, it took few weeks to do it. How long it took you to actually get to the point for the implementing everything with the long term approach?
I will have to say, unfortunately, 2 years, but that's not our fault. It doesn't take 2 years to build this. Uh, but we were doing a lot of these things at the same time. So we had some large clients already, and we constantly had to fix something and then really, yeah, debug something uh, quite difficult on the Kotlin application. Therefore, we couldn't invest more than, if I recall correctly, like 30% of the time, 30% of our sprints we couldn't dedicate to building this long-term approach. So for the beginning, we spent like maybe like a month and a half or something like that for this first part. But then for the second part, also you have to understand that we are dealing with business here. You have all been there. If it works, fine. If the business is working somehow, they don't want to put too much money and too much effort into modernizing it. they they want to. Yeah, we were constantly getting some requirements for the new features, and then we had struggled to explain, yeah, let's don't build that new feature before we finish this thing. So yeah, we don't have to do it twice, but yeah, sometimes you just have to let them win, then build it their way, and yeah, choose wisely which battles you want to fight.
Yeah, definitely, it's like that. Cool.
But from the technical perspective, if we would be able to work entirely on this, I think that for this particular project, it would be under 6 months definitely to move it. Yeah, as is. So without any new functionalities, as is, and we had a team of something like 3 FTEs, so three people, including some DevOps capacity, including some testing capacity. So it was a very small team, uh, but still it's manageable in some reasonable amount of time, and it ended up actually being much more cost effective, because as expensive as Redshift sounds, believe me, uh, Postgres that can run a couple of terabytes is much more expensive. Like if you want to run the Postgres database, and also they had a situation where they were like scaling up the EC2 instance, original EC2 instance. They were like scaling it up to one of the biggest thing that AWS offers you. So it was costing like 5K a month or something like that. So even though some of these services are expensive, it's still, yeah, for Redshift, this amount of data is pretty much nothing. For Postgres, it's dying amount of data, but for Redshift, it's a very small. So yeah, it was very simple. Something that's more costly than doing, definitely more costly than doing it old-fashioned way, is QuickSight, because if you build it in React frontend, it's free. I mean, it's free to run it, not free to build it, definitely.
Developer, but
Sorry?
you pay for the developers, so
Yeah, yeah.
then you will get
So
it months instead of hours.
true. And for the quick site, as you are perhaps aware, you have some places for the seats, and where you have actually viewer and you have the creator, etc. But it was directly reflected on the customers. So pretty much customers directly were paying for that, and they were very happy actually to pay something extra for the creators so they can modify their dashboards more, etc. So it was more costly. That particular part was more costly, but no one complained about it. It was definitely worth it. But in the end, I think um, that we like took down the price like twice. Like they were paying half what they were paying in the beginning, but with much more customers, with actually much more traffic. I'm not saying it's all because of the cloud native services. Some of the things were built a bit wrong in the first place, so we saved something on that. But in the end, yeah, the client was very happy just because of the cloud cost itself.
Really good. Nice.
And the important thing for the future with this particular project, if you take a look at everything that is shown, you can see that there is some code in these Lambda functions, and there is some code in these batch functions. But as I said, these batch functions are just fetching something from the API and storing it S3 bucket as is. So no extra processing. So you can imagine that maintaining that code is extremely simple. Lambda functions are, by definition, by nature, meant to be extremely simple. So just fetch something from the Redshift. So just fetch something from the Aurora. Fetch something from the Elasticache. Put something in Aurora. Put something in, etc. So they were also very simple to maintain. And the glue had some code, some Spark, but it's you can also do it visually, and again, not too much of it. So we had when we came to the project, I remember that we couldn't put even any media developer to that. We had to put senior developers or over to be able to understand what the hell was happening in that Kotlin application and in that React application. In the end, we ended with something that's much easier to maintain. Some of these things could be done even by the business itself without any programming knowledge for some of these things. Yeah, the developers with some very low experience could do it. So it's again, it's a big game changer cost wise for the company.
Okay, great. Um, what are the key takeaways from this?
Yeah. Yeah, we are going to get there. I was I was wondering if there are some more questions regarding the previous slide. If something pops up to your head, please ask it. It's still not too late. But I were talking a lot, I think, already. So we should sum up whatever. We should sum up what's most important out of this. So first thing first is the difference between being in the cloud and difference between going cloud native. That's something, again, I think that's some of the most valuable advices that I got throughout my career were regarding how to talk to business, not how to architect something. So that's what I'm also trying to push it to people who I'm tutoring somehow. Uh, so that's why I will try to give you as much firepower as possible to talk to the business. What happens when they tell you, yeah, we are on the cloud already? So that's what I wanted to show you, that you can challenge that. You can challenge that being in the cloud is enough, because it's usually not enough. The other thing is build trust with your business, build trust with stakeholders, meaning that you have to decide on realistic targets, meaning that you cannot solve it all in one go. So think about it gradually, and even if you can solve it in one go, decide what will you do and how you are going to do it. Rely on expertise always. There are tons of materials um, over there. Try to find something that, I know that you're all working on something that's fun and unique, etc. But that's not always the case. So most probably someone will have some similar situation like you do, and you will be able to find something that's a good starting point. Uh, then think about your platform as your platform, and try to fit everything that I said within your particular use case. So there are some different strategies, but you need to think about them in your particular solution. So if you're having like 10,000 or hundreds of thousands of users, please don't go for the big bang, no matter how much you would love it. Just not to touch that old code ever, and then just to do something fun. Please don't do that. Somewhere else it's going to be perfectly fitting. So think about these strategies, and yeah, understand that you have to decide for that particular
Yes.
situation. Again on the business, but again on the uh, building trust with the business. Yeah, you can see maybe from my talk that for a while I'm not only technical person. I'm also a engineering manager, so I also have to talk a lot with the business and to manage a lot of people. And the best thing that you can do is prove them prove them that the way that you're doing it is going to work as soon as possible. Meaning, look for some quick gains. Do something that you can. Don't start with, "Hey, I will talk to you in 6 months after I finish this." Find something that you can do in a couple of weeks, and then they can see it's going well, and then they will be just better, and you will be able to push more for something that you know that's good enough. When you build trust, it's much easier. And then in the end, yeah, enjoy yourself, and make the team enjoy the project by creating something um, that's yeah, long term, sustainable, something that's really built the best perfect way. But as I said, not before you fix these things that are burning first. That was pretty much everything that I wanted to share in this session. Yeah, feel free to ask any questions about any of this that I said, and I hope that yeah, of course, we are not going to work. I don't know that there are too many companies that are doing the same thing that my company did over there. So you won't have that particular use case, but I hope that I inspired you to find some similarities in some other projects, and then to use some of the knowledge that I try to pass to you.
Yeah, we all wish to start and work on a greenfield project where we can set up everything from scratch, but usually it doesn't happen, as you said. So we are always starting with something that was built either by us or from someone else that we have inherited, and we need to do this in parallel. So yeah, definitely there are ways to go in, and thanks once again for taking the time and sharing your experience and how we can actually modernize application and how to get to the end goal, no matter what the road is to get there. So once again, Marco, thank you for accepting and being a guest for this and for sharing from your experience. And
Thank
for
you for inviting
yeah, we will definitely chat again in some other occasion, and we will be more than glad to have you again back. And in
me.
regards to Yeah. In regards to what's coming next, for May, we already have something booked, and me and Anna will let you know shortly. So thanks to everybody who attended. Have a good evening and see you.
Thank you very much.
Bye
Bye
bye.
bye.